Alright guys, time to get started on lesson 68 homework. Great thing about this is that there are only 16 problems. So let's make our way through numbers 1 through 5, 15, A and B, 16, 21, A, B, and C, 24, and 27 through 30. Beginning with number 1. Determine the degree of each polynomial, and we've got 3 of them to look at. The first one here for number 1, 14 x squared y cubed z to the 4th. So to find the degree of this polynomial, which happens to be a monomial, I'm going to add the exponents, remembering that the constant doesn't have a degree. So 4 plus 3 plus 2 is 9, and that's it. The degree of that monomial is 9. Number 2, 12 q squared r plus 4r minus 10 q squared r to the 6th. Okay, to find the degree of this polynomial, what it's asking me for is what is the highest, which one is the term with the highest degree. So let's do them one at a time, okay? So this term right here has a degree of the q is squared. There's nothing here, don't worry about this 12. The q is squared, the r has an implied exponent of 1. So the degree of this term is 3. The degree of this term, 4r, remember there's an implication here that this is r to the first power, okay, so that's a degree of 1. And the degree of our final term here, don't worry about that, q squared, r6, I add the exponents together and I get 8. So what that means, they're asking me here, is what is the degree of the polynomial? If there's more than one term, it's asking which term has the highest degree, and it's this one. And so the degree of the polynomial is 8, because that's its highest degree. All right, number 3. 5 x to the 4th z cubed plus 4x z. Again, I need to figure out what's the degree of each term in this polynomial, and then I choose the one that has the highest degree. So this one has a degree of 7 because 4 plus 3 is 7. I've got 2 implied 1s here, so this term has a degree of 2, and this is the highest degree. So that's the degree of the polynomial. 7. Number 4. Simplify the radical, and they are asking me what is the square root of 1 over 48. Okay, in order to do this, guys, don't get too hung up on the fraction here, okay? So I could write this as, well, I could write it as the square root of 1 over 48, but let's just go ahead and do, let's do our, we already know that the square root of 1 is 1, right? Because 1 times itself is 1. So really all we need to do is factor the 48, because I don't immediately know. I know that the square root of 49 is 7, but this is a 48. So let's go ahead and factor it. 6 and 8. I already know that this is 3 and 2, so that 6 is going to stay in there. Well, maybe not. Let's do it for good measure. So we don't know what's going to happen with this guy. Okay, so 4 and 2. Ooh, good thing I did. And a 2 and a 2. Now remember, anytime, here are the factors, right? The prime factors are here. And I've got 2 pairs of 2 and a 3. Okay, so I know that I can pull 1, 2 out from here and 1, 2 out from here, but remember that they're in the position of the denominator. So that means I can pull out a 1/2 and another 1/2, okay, and I took care of those, and I still, inside, okay, that radical, I still have the square root of 1/3. Now, when I do my further simplification, 1/2 times 1/2 is 1/4 times the square root of 1/3, and that's the answer. Okay, so it's just this right here, 1/4 times the square root of 1/3. Okay, number 5, similar. The square root of 4 over 25x to the 4th. Ooh, I like this one. I like this one a lot. It might be helpful for me to see it this way. I know what the square root of 4 is, and I know what the square root of 25 is. I have those memorized. Okay, so I'm not going to worry about factoring those because I can see. I know square root of 4 is 2 and the square root of 25 is 5. It might be helpful for me to remember that x to the 4th is the same as x squared times x squared. Which means every single thing here is a square. So everything gets freed, okay, from our radical here. So the square root of 4 is 2. The square root of 25 is 5. The square root of x squared is x. And the square root of x squared is x. When I simplify that, I get 2 over 5x squared. Okay? So that's my answer. I don't need another equal sign there. Sorry, I don't know what I'm doing. But I'm going to, well, can I just put a box around it? Is that all right, guys? Okay, so that's my answer here for number 5. Pretend like that's in my column. Okay, number 15. Big jump to 15A and B. Use the following system to answer the problems below. X equals y plus 2 and 2x equals y. Cool. Okay, so if I have something like this and I can see that y equals 2x, I'm going to just go ahead and use substitution. Because if this equals 2x, then that means I can just take 2x and I can stick it in here for y and then solve for x. So that's what I'm going to do. I'm going to rewrite these equations here as x equals, instead of y, I'm going to put 2x in, because they're equivalent, remember? Plus 2, don't forget that. Okay, so I just substituted in 2x for y right here. Now I can go ahead and solve. So I'm going to move this 2x from this side of the equation over here. X minus 2x is negative x equals 2. A little tricky, but not for us, right? I can flip those signs around and multiply this entire thing by negative 1, which will transform this to x equals negative 2. Okay, because I just multiplied this entire guy here by negative 1 so that I could change those signs and end up with a positive x. Okay, cool. Oh, it told me to it told me to graph the system. Oh boy. And I just started solving it. And I'm not going to be wrong, but this isn't exactly what they asked me to do. I'm going to finish it anyway, okay? Okay, so I know that x is negative 2, so I'm going to take this value here for negative 2, okay? And I'm going to put it back in here into the 2x equals y, because then I just have to do 2 times negative 2, because that's my x value, equals y. So I get negative 4 equals y. So my solution is negative 2, negative 4. Now what it actually asked me to do, I might have cut that off, sorry, as I was solving it there for you guys. What it actually asked me to do here for letter A is to graph the system. So I'm going to draw a coordinate plane here. This is my origin point, and it's asking me to graph these two lines, okay? Both of those lines there, which isn't going to be too difficult. So let's just make sure 2, 3, 4, 5, 6, okay? So that's going to be 1, 2, 3, 4, 5, 6. I'm going to call that 6 right there. 1, 2, 3, 4, 5, that's negative 6. And 1, 2, 3, 4, 5, 6. We'll call that negative 6. Okay, this is a positive 6, right? 1, 2, 3, 4, 5, 6, yeah. When I go to graph this line here, x equals y plus 2, I want it in the form y equals. All right, so let me just do a little bit of manipulation. It won't take long, it won't be hard. Y equals x plus 2, okay? So if I want this to be y equals, then I need to move this 2. Because I need to get y by itself, and I need to subtract 2 over here. I'm going to, in my head, just kind of flip this around, flip the position. So it's y equals, right? And I've got x minus 2 on this side. All right, now that I have it in that form, okay, I can look at that was my top equation, right? Yeah. My bottom equation is already in a y equals form, and that's what I want when I'm graphing lines. I want them to be in the form y equals. I just flip-flopping them to the other side, y equals 2x. Okay, when I go to graph this line right here, I can see that the slope is 1, so it's going to be up 1 over 1, right? And it's going to hit the y-axis at -2. So I put a point right here at -2, and then it's up 1 over 1, up 1 over 1. Look at that, I just found where it hits the x-axis. See that, guys? Did I do that right? Oh, you know what? This can't be right. Because look at, my x has to equal -2. So I think when I did this, I must have flipped it around wrong. Okay, so let's see. Yeah, I sure did. Right? Because if I have this, my -2 on this side and my -2 on this side here, did I do that right? X -2, x -2 should be, oh, for heaven's sake. Y equals 4. Did I do that wrong? Uh-oh. No, this is the correct solution where x equals, oh, that's because this is this is the solution to the set. Okay, we're doing fine. We're gonna keep going. I didn't do that wrong, I did it fine. Okay, here we go. So, I'm just gonna keep going. Up 1 over 1, up 1 over 1. All right, here we go to the next one, just to be sure. You don't really have to plot like all of these points, but I just wanna make sure I have a straight-ish line. Okay, okay, here's the line, approximately. Make sure you put arrows, so it's not just a segment, it's an actual line. And then I got, so I did that one. I'm gonna graph y equals 2x. I know this one goes to the origin because it doesn't have a b. See how this one had the -2, that told me where to put it on the y, where it intercepted the y-axis. This one doesn't have anything. It's just got a slope, so that tells me it hits here, and then my slope is up 2 over 1, right? So up 1, 2 over 1, 1, 2 over 1. It's going to do the same thing here, right? 1, 2 over 1, 1, 2, and over 1, 1, 2, and here. Alrighty. So now I should have done this in 2 different colors, but I've got here, there is my second line. The point at which they intersect, which is approximately here, is their solution. Okay? It's a little bit hard to tell from my graph, but if I check my work here, which I just did sort of automatically where I started solving this system of equations, I can see that I'm right. 1, 2, and down 4. 1, 2, 3, 4. There's the point where they intersect. If you had done this, if you had put these lines in your graphing calculator, it would have showed you that same intersection point. But our math here was right, and it's proved by our graph. Okay, so I graphed the system. This is letter A right here. 15A, I graphed it. 15B says determine the solution and verify your solution using a graphing calculator. So if you want to go ahead and put that in your calculator, that's fine. The answer to 15B, the intersection point, is what we found when we solved the systems of equation and proved in our graph here. So it's -2, -4. Whew. Okay, let's go on now to number 16. See if I've got enough space here to do 16. Jorge is adding a rectangular family room onto his house. The dimensions of the room can be represented by a width of x plus 6 feet and a length of 2x plus 5 feet. All right, I'm going to just draw. It's really helpful for me to draw pictures whenever I can to see what I'm working with here. So the width, this length from here to here, is x plus 6. This is Jorge's living room. And the length is 2x plus 5. Alrighty. Write a polynomial expression for the area of the new room. So I know area is going to be length times width. So area equals, this is the length, 2x plus 5 times the width, x plus 6. Okay, I'm going to go ahead and use FOIL to help me multiply this polynomial. You guys remember that? So we'll multiply the first terms, and then the outer terms, and then the inner terms, and then the last terms. First terms, 2x times x is 2x squared. Outer terms, 2x times 6, and it's a positive 6, is positive 12x. Inner terms, plus 5 times positive x is plus 5x. So I know I'm going to be able to combine these. And my last terms, plus 5 times plus 6 is a positive 30. One last thing to do here, which is just to combine my like terms, which are right there. I have 12x and 5x, so they're just going to stay x's. 2x squared plus how many of them? 12 plus 5 more is going to be 17x plus 30. I want to remember what the units were, and I think it's square feet, so it's going to be feet squared. I'm just going to go ahead and put a box around this. If you want to transfer it to an answer column, feel free. This is perfectly acceptable. All right, that is it for that one. So we are on now to number 21. Okay, number 21. Draw a coordinate grid, numbering from -6 to +6 along the x and y axis. Hey, that's what I just did, isn't it? Let's do it again. Okay. So, x and y, right? So I'm going to go ahead and start with y. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 5, 6. It's important that I label these. I'm just going to go, let's see, that's my 1, 1, 2. I'm going to put a 3 right here and a 6 right here. Positive 3, 4, 5, 6. Negative 3 right here, and -6, and -3 here, and -6. Okay, so that I know what those units represent, what my tick marks represent. Okay, will a line that passes through the points 0, -4, and 5, -2 be perpendicular to a line that passes through the points -2, 5, and 0, 1? We're going to do this in 3 steps. Line 1 passes through points 0, -4, and 5, -2. Line 2 passes through the points -2, 5, and 0, 1. Graph the answers. Okay, so I'm not going to do the math yet. I probably am going to need to do the math here to make sure that I can determine the slopes of each one of these lines accurately, just in case my, grid is not quite to scale. But let's do line 1 first. So line 1 passes through 0, -4. 1, 2, 3, 4, this point. And 5, -2. 1, 2, right about there. Okay. Passes right through there. I wish I had something straight that I could help myself make a straight line here, but I'm going to do my best to just show there's line 1, approximately. Okay, line 2 passes through the points -2, 1, 2, 5, that's just about here, and 0, 1, right there. Are these two lines perpendicular? We don't know yet, but I'm going to graph the lines. Now it says write an equation for both lines. Write an equation for both lines. So I already have the y-intercepts for each one. Okay, so here's line 1. The information that I have is I know the y-intercept. I know where line 1 crossed the y-intercept because they gave me that point. So I already know that it's -4. If I can find the slope, then I can write the equation. Line 2, the y-intercept is, this is this one right here, right? So this one passed through the y-intercept at 1, and so now I need to determine the slope for this one as well. I can do this a couple of different ways. All right, guys, if you want to use your formula for slope, do you remember what that is? So m equals y2 minus y1 over x2 minus x1. That's probably your best bet. You could try counting if you want to. Okay, so line 1 is, this one was my orange line right here, and I just have to remember what these points are, right? So this one is 0, -4, and this one was 5, -2. So I could count, right? So here I am at -4 and I go up to -2. So I'm going to go up 2, 1, 2, and then over 5 to get to this point. Up 2 over 5. So I know that the slope for this line is 2/5. I can do it that way, or I could put the points in. Either way, I should end up with 2/5. Okay? So if I do y2 minus y1, let's have this be y2, -2 minus, here's my y1, minus -4 is going to be +4 over x2, which is 5, minus 0. I end up with 2 over 5. Okay, so I can do it either way. Line 2, which is right here, I can tell has a negative slope. Okay, and if I plotted these points correctly, which I should have, then this one, which is -2, 5, and this one, which is 0, 1, I could count how many units do I move down, right? So I'm going to go down 4, 1, 2, 3, 4, there. And then I go over, let's see, how am I on right here? This -2, 1, 2. I go over 2, so down 4 over 2, down 4 over 2, which is equal to -2. So my slope is -2. Again, if I want to use this equation, I can. Here are the points that I have. Okay, so I would have m for this one equals y2, which is 1, minus y1, which is 5, over x2, which is 0, minus x1, which is -2. So 0 minus -2 is the same as 0 plus 2. Oops, that's supposed to be a 2. Did I do that right? There we go. 1 minus 5 is -4. 0 plus 2 is 2. And sure enough, I end up with -2. So either way you wanted to do it is fine. When I write the equations for this, now I have all the information I need because I've got the slope and I have the y-intercept. So I just plug them into my y equals mx plus b formula. Y equals m, slope is m, 2/5, plus b, so that's -4. Oh, I forgot the x, sorry, mx plus b. This line, y equals, slope is -2, -2x. The y-intercept is 1, plus 1. Okay, so now I've got equations, and that's what they asked me for both of those lines. They're asking, are the lines perpendicular? Perpendicular means that their slopes need to be negative reciprocals. Okay, so this is the answer to 21A right here. Here's 21B. There's one line, there's another line. Here's 21C. Are they negative reciprocals? Are they perpendicular? The answer is no, because the slopes are not negative reciprocals. The negative reciprocal to 2/5 would be -5/2, and that's not what we have. They're close, but not quite there. So I needed to do that math, or be very careful with my graph to figure that out. So no, the lines are not perpendicular because their slopes are not negative reciprocals. All right. That's a lot of words. Reciprocals. Okay? Whew. Alrighty. Just a few problems left. Number 24. Turn page. Ooh, this looks easier. Okay. Find the common solution for each system of equations. I like the way this looks. This looks like an easy substitution. First equation is y equals 3/4 x plus 3. Second equation is y equals x. Great. So if y equals x, then I can just take x and substitute it in here for y, right? Because they're equal to each other. So I can take this and I'm going to say x equals all of this. Because I just substituted in x for that y. Okay, and when I subtract 3/4 x from this side and I subtract it from this side, I'll end up with 1/4 x equals 3. I'm going to multiply this by 4. Get rid of it over here, and I end up with x equals 12. I only have half an answer. I need a y value. So if x equals 12, here's the best part. Look, if x equals 12, then I just take the 12 and I put it in here for x, and I get y equals 12. I love it when that happens. And there's my answer, 12, 12. Number 27. If two standard number cubes are rolled 100 times, predict the number of times that a sum of 7 or 11 will be rolled. All right, you guys, if you don't have that little chart in front of you, the one where we had all the sums listed for rolling two number cubes, and what they mean by that, a number cube has 6 sides to it, then we got to think a little bit. What are all the possibilities of getting a sum? We already know that the total possibilities on those two number cubes, if we remember, right, is we have 36 total possibilities or outcomes for rolls, right? So I know that that's what's going to go in the denominator. But how many of them could possibly be a sum of 7? Let's think about it real quick. If one side is a 1, the other would have to be a 6. And I could do it the other way around. If one side was a 6, then, right, this is a sum of 7. Okay. I could roll a 2 and a 5, or a 5 and a 2. I could